Lake Winnipeg is among the largest lakes in the world and is changing due largely to human activities. In order to understand, mitigate, and manage these changes, information is needed. Motor vessel Namao is owned and operated by the Lake Winnipeg Research Consortium and is used to carry out multidisciplinary research and monitoring on Lake Winnipeg. When not working, the Namao is harbored in Gimli, Manitoba. Hi, my name is Karen Scott and I coordinate the science program on Lake Winnipeg. This presentation is a glimpse into the Lake Winnipeg Research Consortium, who we are, what we do, and why we do it. Welcome aboard the motor vessel Namao. A partial definition of consortium is a group formed to undertake an enterprise beyond the resources of any one member. Before I talk about who is part of the Lake Winnipeg Research Consortium, I'd like to take a step back in time to 1997, when two somewhat serendipitous events occurred. The first event was the flood of the century of the Red River. Now this is of interest because the Red River flows into Lake Winnipeg, and the scientific community had concerns about what those floodwaters were carrying into the lake. The second event in 1997 was the Aids to Navigation program was privatized. The Namao is key to this program because she was originally built as a buoy tender used by the Canadian Coast Guard to deploy and retrieve navigational buoys on Lake Winnipeg. So when the program was privatized, the Namao was no longer needed and was put up for disposal as a Crown asset. So 1997 was key. We had an enormous flood flowing into Lake Winnipeg, a retired ship, and a vision shared by a number of dedicated individuals. And those were the ingredients to form the Lake Winnipeg Research Consortium in 1998, and we became a registered charity in 2008. Back to the members of the Lake Winnipeg Research Consortium. We have 6 classes of membership: contributing, research, participating, general, life, and honorary. Anyone can become a member. You don't have to contribute funding or be doing research on the lake. We also have 3 officers of the corporation appointed by the board of directors. The managing director is Al Christofferson. Programs, science and education is me, Karen Scott. And superintendent of marine operations, everything ship related, is taken care of by Ryan Johnson. The Namao requires a crew of 9 just to run the ship. And then we have a second crew on board, and that's the science crew, typically made up of our research members. And finally, there's a board of 9 directors, which provides financial, governance, and strategic oversight to the organization. This presentation is focusing on the activities of the research members of the consortium. The Lake Winnipeg Research Consortium facilitates multidisciplinary research and monitoring, or science, on Lake Winnipeg. What exactly does that mean? You can think of multidisciplinary science as whole ecosystem science, looking at the big picture. For example, the biological components of the system are the food web. And as the name suggests, it's all about food. Who is eating whom, from nutrients, which are consumed by algae at the base of the food web, all the way up to the top predators like pickerel, and what those interactions are like and how they're changing, for instance, due to invasive species. Another component of the system is the chemical component, natural water chemistry, but also contaminants introduced by humans, such as pharmaceuticals, pesticides, mercury, microplastics, estrogen-like compounds. Many of these enter water bodies. And the physical component of the system, that includes currents, how water moves, mixing, temperature, oxygen, how far light penetrates into the water column. It's not just at the surface of the lake. The surface and bottom waters can be very different. And the sediment is a whole other world, especially at the interface between the sediment and the water. Very dynamic place. A whole ecosystem includes the whole lake. which in Lake Winnipeg's case is enormous. In terms of surface area, not so much in terms of water volume, because it's a very shallow lake. It is a regulated system for hydroelectric energy generation. It's very dynamic and heterogeneous. This is a satellite image taken in the spring that shows just how different this lake is from north to south. There's ice still on the lake. You can see the brown water on the right is high dissolved organic carbon coming in from the boreal forest. And you can see the influence of the Red River coming in the south end of the lake. Very dynamic system, very heterogeneous. And that's why we need a fairly extensive station network. We have 50 offshore stations, 12 nearshore stations in blue, 3 outflow stations at Warren Landing and 2 Mile Channel. And each of these stations are visited three times a year, spring, summer, and fall. We also deploy and retrieve the ODAS weather buoys to get the marine forecasts, and we have a series of moorings on the lake, which I'll discuss later. Many of the stations are too shallow or dangerous to access, and we launch a workboat to sample at those stations. So obviously no one individual has the intellectual capacity to do this alone, and no one agency has the capacity, financial or otherwise. And that's where the science team comes in. We facilitate for the research members of the consortium. We have the on-lake program, and we also have a winter program where we convene the science team. The most prominent science members on the lake are Environment and Climate Change Canada and the province of Manitoba, and also Fisheries and Oceans Canada. Universities tend more towards short-term research projects. They add to our knowledge, but end once the project funding dries up and the graduate student moves on. To give you a feel of what some of this work looks like, I've put together some slides that include some of the equipment depicted in this image that we deploy on a routine basis from the ship. So you'll have a little break from me talking before we wrap up with why we do this. Why do multidisciplinary research? One reason is that Lake Winnipeg is changing, and it will continue to change. With climate change, the introduction of exotic species, and ongoing pressures from human activities. Some changes are visible and obvious, like algal blooms or eutrophication, which is caused by excess nutrients entering the lake. And zebra mussels, also very visible as they foul our beaches. Other changes are not visible, like oxygen, temperature, changes in the food web, microplastics. You can't see them, and they need to be measured and quantified in order to identify them and to establish trends. Is it getting better? Is it getting worse? Related to a changing Lake Winnipeg is that everything is connected and in very complex ways. For instance, let's pretend we have a scenario where a tremendous amount of effort goes into reducing nutrients from entering the lake. But the lake doesn't seem to respond in a favorable way. Maybe it even gets worse. Why? Well, you can't answer that question without looking at other processes that influence the growth of algae, such as light, temperature, and mixing, as well as factors influencing nutrient cycling within the lake, such as zebra mussels or phosphorus from the sediment. Which brings us to the last reason in support of multidisciplinary science. Data informs management decision-making, or at least it should. Sometimes politics trumps science, but ideally, working with the best available information is preferable. For Lake Winnipeg, we didn't have a lot of information on the whole system until recently. You can see there, it wasn't until the Lake Winnipeg Research Consortium started their surveys in earnest that we really started to acquire long-term data sets on Lake Winnipeg. So we're finally able to work with information instead of guessing. And that's crucial for understanding change and managing that change over the long term. We can't go back to a pristine state, but we can manage change going forward, making decisions that sustain the ecosystem instead of making decisions that cause further deterioration. Models are being developed using those long-term data sets, and they will help predict the lake's response to changes in nutrient loading, and they'll also help predict the lake's response to the effects of zebra mussels on nutrient recycling. Lake Winnipeg is changing and will continue to do so. Everything is connected in very complex ways, and data informs management decision-making from water quality to the fishery. Before I leave you, I'd like to say a few words about our education program. It might be of interest to educators and students. We have a university-level scholarship named after the late Dr. Herb Lawler, founding director of the Consortium. We also have a prize for younger students offered through the Manitoba School Science Symposium. This one's nice because you get a cash prize and you get to come out on the ship with our science team. And we also have the Lake Ecology Field Program. This is a hands-on program where you come on board the Nemeo and you sample and do analyses on board. So it's a fun way to learn about Lake Winnipeg. I hope this presentation has sparked an interest in what we do and what you can do to minimize your impact on Lake Winnipeg. If you'd like more information about the science or our programs, there's lots to be found on our website. Thanks for listening.